today we're moving back into chapter 7. So if you recall, the beginning of chapter 7, we talked a lot about exponential functions. All right, how to model growth, decay, compounding interest with exponents. Now, for the rest of the chapter, we're transitioning into what are called logarithms. But logarithms are very connected to exponents. So, to kind of review a little bit of what we talked about in the first piece, let's remember how to rewrite numbers into exponential form. So, we want to write all four of these numbers as either a base of 2 or a base of 3. Now, what I mean by that is 8 can be written as 2 to the third power. 16 can be written as 2 to the fourth power. 27 is 3 to the third power, and 81 is 3 to the fourth power. So that's one thing we're going to have to be able to remember, is looking at a number and being able to recognize when it's a power of another number. All right, and we are going to print off again, so you'll have your powers chart to help you recognize these. Now, where do logarithms come into this? Well, we're going to learn how to write all numbers as the powers of a common base. So that's this power of logarithms. Now, when I say logarithm, what am I talking about? Well, what I mean is logarithms are the inverse of exponents. And again, when I use the word inverse, I'm talking about they undo each other. So a logarithm will undo an exponent. Recall that exponential equations take the form of y equals b to the x. All right, and again, that's where we started. That was the beginning piece of chapter 7. And I know it's been a while, but I need you to remember that piece. So that's exponential form. Now, the inverse of that. Now, again, when I say inverse, I'm talking about switching the x and the y. So to get to here, notice all we've done is we switched the x and the y. Remember in chapter 6, we talked about finding the inverse of an equation. You do that by flipping those two variables. And now, to solve for y, we use the logarithm. All right? So these are actually the same equation. Okay? Same equation, just one is solved for x, the other is solved for y. And in order to solve for y, you use the logarithm. So you read that statement as log base b of x. Now, b is always going to be a number, all right? Log of a certain number of x will equal y. Now, there's some stipulations about the b. That b must be positive, and it can't equal 1. Another way to think of this as logarithm y is the exponent to which b must be raised to get x. Now again, this is really wordy, okay? Probably doesn't make much sense yet until you actually see some of it in action. However, the thing I want you to consider, these two things are the same. They're written in a different form. There's a logarithmic form, log base b of x equals y. And there's an exponential form, b to the y power equals x. But they are, in fact, the same thing. Now, one thing we're going to have to know how to do is go between these two forms, all right? That's the way that we're going to be solving these logarithmic and exponential equations for the rest of this chapter, is by going between the two forms of logarithm and exponent. So, let's look at this. Log base 2 of 8 equals 3. So remember, a logarithm is saying, what power do you have to take b to in order to get that x? So here, this is saying, if I take 2 to the third power, that's going to give me 8. Now, when my teacher taught me this, my teacher introduced it as calling that Mr. Loopy. Again, may seem kind of cheesy, but if I remember that over 10 years later, it means that it's kind of an effective tool to think of it. If you just get in that loop pattern, it will show you how to do these, okay? It'll help you piece it together. But again, the goal is you're always taking that b. b to that power equals that. And again, if you remember Mr. Loopy, as cheesy as that may sound, it might be useful. It might actually help you. So let's try it again. The base to the solution. So 3, oh, I'm sorry, and I almost wrote that wrong. 3 to the negative 2 power equals that 1/9. So the solution to the logarithm is actually the exponent. It's showing us the exponent you take that base to in order to get that number. That's what a logarithm represents. All right? So I think this direction is a lot easier because you can use this Mr. Loopy concept, if you will, in order to obtain that exponential equation, to rewrite it. Now, it gets a little bit more difficult when you're going the other direction. All right? So when I give you an exponential form and I tell you write in logarithmic form, it gets a little bit trickier. Now, the things that we want to remember, the answer to the logarithm, the power is the answer to the logarithm, okay? So the exponent is what the logarithm equals, and the base of the exponent is the same thing as the base in the logarithm. So the idea of base, even though it looks different, it is the same concept. So what do I mean by that? Well, here, the exponent is the answer. All right, so remember, the exponent is the answer to the logarithm. When I'm taking the logarithm, the base is still the same, and then I'm taking the log of that number that's alone. So here, log base 10 of 100 is 2. And again, just double check what it's saying. It's telling you 10 to the second power equals 100. And that's what you wrote. That's where the problem started. So you can use that kind of Mr. Loopy idea to remember or to go back and check your work. Let's try it again. So remember, my exponent, if I'm writing in logarithmic form, my exponent is my answer. The base is still the same. So this is going to be a log base 3. And I'm taking the logarithm of that number 81. And again, let's check this. This is telling me 3 to the 4th power is 81. Is that where I started? Yes, it is. All right. My exponent is my answer. Log, and then those bases stay the same. So log base 3 of that number, so of 1, is 0. So what's it saying? 3 to the 0 power is 1. All right, the solution, or my exponent is my solution. My bases are the same, so that 2 is my base, and I'm taking it of 0.125. So what is this saying? 2 to the negative 3rd power is 0.125. So again, I would always use those loops there to double check my work, to make sure that I wrote it properly, because it's easier to see in that direction. So now, why do we want to be able to write it like that? Why is that useful to us? Well, that's how we're going to evaluate logarithms. Now, I know this looks like a lot. We have 9 that we're going to go through. But because this is such a brand new skill, it's not a difficult skill. It's just very, very brand new to you. So when I give you a logarithmic statement, when I give you this, so for example, log base 5 of 125. When I give you that, how are you supposed to solve it? Well, the first way we're going to do is without a calculator, all right? We don't need a calculator for these. So the first thing I'm going to do, I'm going to write it in exponential form. So I'm going to set that equal to x. I want to know what that is. So on my paper, I'm going to write equals x. Now I'm going to put it in exponential form. 5 to the x power equals 125. All right, so I need to think to myself, 5 to what power gives me 125? And again, even though you won't have your calculator for this piece, you will have your powers chart. So all you have to do is look at your powers chart. Powers of 5. 5 to the first is 5, so no. 5 to the second is 25, so no. 5 to the third, there it is. 5 to the third is 125. So what does what does it equal? This equals 3. Remember, that exponent is the answer to the logarithm. So that's our strategy for all of these. And again, the goal is just practice, 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 seeing this enough times that it makes sense. So let's do another basic one. 3 to the x equals 243. So again, look at your powers chart. So we know 3 to the third is 27. 3 to the 4 is 81. 3 to the 5. 3 to the 5 is what I'm interested in, because 3 to the 5 is 243. So that means that my solution, the exponent I have to take 3 to get 243, is 5. All right, let's try this next one. 2 to the x is 1/4. Now, this one's a little bit tricky. When you get into fractions, this is why we have so many examples, because there's a lot of different things that can play out when you have things like fractions happening and all of that. So I want you to think. 2 to the x equals 1/4. Now, remember, if we take a negative exponent, that moves it to the denominator, right? That's what moves it down. So what I'm going to do is I'm going to think of this 1/4 2 to the negative 2, because 2 squared gives me 4. But if I want that 4 in the denominator, I need a negative exponent to move it to the denominator. Okay? So when you have fractions, you have to start being careful, okay? Because it takes a negative exponent to move its location. So if I have 2 to the x equals 1/4, well, 2 squared is 4, so 2 to the negative 2 would be 1/4. So that would mean this x is a negative 2. So again, just be careful when you're doing these, all right? Whenever you have fractions, keep in mind when you need to start using negatives. All right, I'm going to erase this so I have some space for Mr. Loopy. So I want to know what that equals. So 4 to the x equals 32. All right, now this one you may notice. 32 is not a power of x, all right? Now, we can still solve this using exponents though, because while 32 is not a power of x, or 32 is not a power of 4, both of these are a power of 2. 32 is 2 to the 5th power. What about 4? Well, 4 is 2 to the 2nd power. And then I still have my x as well. So that's another thing to recognize, is sometimes you have to rewrite both sides, okay? Because here 32 is not a power of 4, but however, both 4 and 32 are powers of 2. So now, those exponents have to be the same. That's the only way that this can play out. So x ends up equaling 5/2. All right. And I'm going to give myself a little bit more space up here. So 49 to the x equals 1/7. All right, so here's another one where it's getting a little bit tricky. So first of all, if I want to write these, the thing I need to notice, 7 is the square root of 49, right? So here, instead of 7, I'm going to actually say, I know that 7 is the square root of 49. Okay, I'm trying to manipulate it to be the same base as the number that has the x with it. Now, back from chapter 6, hopefully we remember that the way to write those, instead of a square root, in terms of a power, a square root is the same thing as the 1/2 power. Now, thinking back to our other example, I'm dealing with a fraction here. So, to get rid of the fraction, to move it up, I'm going to have a negative exponent. And now, I can finally say I know what x is. The x is negative 1/2. So quite a few steps, but still, as long as you follow that process, you should be able to get there. All right, and for this last one, or not last one in this row, I guess. So 1/2 to the x power equals 1/8. All right, so 1/8. Well, 8 we know is 2 to the third. That's pretty common knowledge by this point, or hopefully pretty common knowledge. Okay? Now, notice both of them are fractions here. So in this case, kind of the cool thing is because both of them are already fractions, if you think about applying that x to this, and why did I ignore it on the 1? Well, 1 to anything is still 1. But I think about this, because both are fractions, I don't actually have to concern myself with negative exponents. Isn't this one of those cases? Can't you just say x is 3? Because if both are in the denominator, that's actually okay. I just can't have one be normal and one in the denominator. That's what doesn't end up working. But if both are fractions, then you can just say x is 3. You don't have to worry about manipulating it with negatives. So I get x is 3. All right, we're almost done. So again, I'm going to give myself a little bit more space here. So here, now, this time, because my variable x is actually in the problem, I'm going to label this a different variable just to avoid some confusion. Okay? So again, I don't have to be calling these x. It's just something convenient because we like using x. But if x is in the problem, I'm just going to use a different variable. I'm going to use y. So here, x to the y equals x to the 5. Now this presents an interesting rule, okay, because I already have a common base both to exponents, so it actually just turns out to be 5. So this is actually a cool little rule that if you have a base and you have that base to some power that you're taking the logarithm of, the answer is actually just that exponent. It's kind of a nifty little rule. Now, until you get really good at that, I would still use this transformation process into an exponential form. But again, just cool little rule that the exponent will be the answer if those two things are the same. In this case, they're both x. This one, 6 to the x equals 1. All right, well, here's the tricky one that I want you to consider. So anything to the 0 power equals 1. Hopefully we know that. Hopefully we can remember that. So if anything to the 0 power is 1, can't I rewrite that as 6 to the 0? So wouldn't this just actually equal 0? So that's another concept I want you to know, is when you're taking a logarithm of any base of 1, you're always going to get 0 because anything to the 0 is 1. So that's the only way to get 1 for these. And finally, our truly last one, 2 to the x equals -4. Now, this one presents a predicament because if I take 2 to the 0, that's 1. 2 squared, that's +4. 2 cubed, that's 8. So clearly that's not going in the right direction. That's getting me bigger numbers. Well, 2 to the -1 is 1/2. 2 to the -2 is 1/4. So if you notice, is there anything I can do, any power I can take to get an answer of -4? And if you think hard enough, you'll know the answer is no. There's actually nothing I can do to get a negative answer to this. So this opens up a predicament because I can't solve that equation. There's no x I can choose to get me that -4. So the last rule that I want you to know, that I want you to remember, you cannot take a logarithm of a negative number. It doesn't work. Okay? So that is the final rule I need you to try to remember. Do not try to take the log of a negative number. Just cross it off. Not possible. Can't do it. All right, so I apologize. This got to be a longer video than I expected, but there's a lot of good information here. Now, I know it's a lot to take in. Don't panic. Just breathe. We will go over more in class. I'll make sure you're comfortable with this. Just please, it is utterly important that you have all this written down so you can reflect back on your notes as you're doing your practice work. But again, just make sure you have everything down. Come back. We'll discuss it in class to make sure that you're really getting it down well. So thank you for watching this, and I will see you in class.